All right, so the important thing to know about a problem like this is what exactly is evaluating a function for, and what is when we have this notation, this f of x. So preferably, whenever I see this, I always tell my students to write it like this. Okay, and I think that is a little bit more familiar with us on what it means to evaluate a function. So for instance, we have our given function f of x, which is x squared plus 1. So let's go ahead and rewrite this over here. X squared plus 1. Now remember, f is really kind of like a name. We have f of x, g of x, h of x. We can really use any letter to represent that. That's representing like the name. X represents our input value, and this is going to be representing our rule. Now, when we change our input value from rather than being a variable to a defined value, such as like f of 1, then what we need to do is take that input value and plug it into the input value inside the rule. So if I have 1 here, then I'm going to replace my x here with 1, so that's 1 squared plus 1, and you can see now we're going to get a value of 2. So another way we can think about this, even though this is going to be the rule, when we plug in a value such as this, which represents our input, then this is going to be our output. Now everything kind of gets a lot more confusing though once we start dealing with more functions to be able to plug in. So for instance now though, if we follow this pattern, if I have f of 1, well what about if I plug in f of, and I'm going to use a different color here, f of x. So now what we're dealing with is instead of replacing my x with a 1, which I did, now I need to replace my x with a f of x. All right, so now my output is not going to be actually a specific value, but it's actually going to be an expression. Obviously one of these expressions right here. So the cool thing is though, we have the expression for f of x. F of x is equal to an x squared plus 1. So now what I'm simply going to do is rewrite my f of x as a x squared plus 1 quantity squared plus 1. Now I need to make sure I can multiply x squared plus 1. So the one thing you do not want to do is say, oh, that's equal to x to the 4th plus x squared, right? Do not do that. Remember, x squared plus 1 means x squared plus 1 times a x squared plus 1. So now I need to apply the distributive property. I need to multiply the x squared times x squared, the 1 times the 1. That's going to be my first and my last. Then I need to do my inner as well as my outer. So let's go ahead and write it out. X squared times x squared is going to be x to the 4th. X squared times 1 is going to be an x squared. 1 times x squared is going to be an x squared. 1 times 1 is going to be a 1. Now we have these two terms, which we can combine. Since they have the same base, which is x, and they have the same power, we can combine them. So like 1 apple plus 1 apple would be 2 apple. Since these terms are the same, we could say we have 2 x squareds. So I have an x to the 4th plus a 2 x squared plus 1. So now what I'm simply going to do is rewrite this over here. This expanded is x to the 4th plus a 2x squared plus 1. But then remember, I have this 1 over here, right? So now I can add the 1 plus the 1, which is going to give me a 2. So my final answer is a x to the 4th plus a 2x squared plus 2. Now you can see that the answer is going to be E.